Hi, everybody, and welcome to Dapper Data's Chicago Food Inspections dataset.
We selected a City of Chicago health inspections dataset. It contained about 250,000 rows covering 10 years of health inspections, plus violations and any comments if they were issued during the inspection. Our use case for the dataset was developing data-driven restaurant guides for a fictional big data conference. We did our initial investigation in OpenRefine. Some aspects of the dataset were very clean and consistent. Things like the risk level, the results, and the name of the violation did not require any cleaning. They were probably selected from a menu. However, some aspects of the dataset were a mess. The city, you can see there were like probably close to a dozen different ways that the word Chicago was entered. Also, the address, inspection type, and facility type were entered by hand or by transcription, and in some cases were not cleanable. But you can see here that when people entered a facility type, they were just sort of entering free text. There were multiple ways that each type was entered. Finally, our biggest challenge was that, at least in this phase, was that every inspection's violations and their comments were packed into a single field. This is one of the largest ones. But as I mentioned, some inspections had up to 23 individual violations. These were all in one field. Because we wanted to have the ability to address individual violations and also to check and clean the data, we tried to sort of split up the violations. First, we split them using the delimiter that was between individual violations, which was a pipe character. This gave us multi-row records with one violation in each row. And then we used some invariant text before each comment to separate the comments into their own column. This allowed us to use a text facet to examine the violations and their comments, which actually led us to one of our big challenges, which was that we discovered when we were looking at the violations that the City of Chicago changed their numbering scheme in mid-2018. So there was one numbering scheme for violations before July 1st, 2018, and another afterwards. This was not something we knew when we went in to start working on this data set. Also, many rows had null values, things were entered as zeros, and there were other missing data that we had to take care of.
So we ended up going back and kind of, based on our initial assessment, decided to conduct an initial cleaning using OpenRefine and then prep to put it into SQL. We're going to load the data into a relational database in SQL with a many-to-many relationship between a row of inspections and those of violations, or table of row and table of violations. It would allow for further investigation and testing of integrity constraints and would be an appropriate structure for our proposed use case, which was querying individual violations. So in our use cases, we decided to produce a report and a Google map of the best restaurants for conference goers to go to within a 3-mile radius of the venue. For our presentation that we were going to have at the conference, we were going to produce a list of restaurants to avoid. And then we were going to prepare data for use in possible future projects via searchable web interfaces such as Kaggle.
So to clean the data in OpenRefine, we converted dates to ISOs and numeric fields to numbers, which allowed us to use facets to check them out and make sure that they were clean. For text facets, we used clustering to clean up the, for instance, multiple variants on spelling of the City of Chicago. Some of these fields were very cleanable. City, there was a limited number of choices, so it was fairly easy to cluster those and determine definitively what was intended in each row. Some fields wound up not being particularly cleanable. We initially intended to be able to limit by specific facility types, which included things like daycares, churches, school cafeterias, and other venues that wouldn't be of interest in our use case. But it turned out that the facility type included so many variations that in many cases we would have to interpret the intentions of the person who made the entry, and we weren't willing to do that. So we cleaned it to the extent that we could, but in many cases we actually couldn't make a determination. We also couldn't do anything about cases where there were like zeros entered for a license number or nulls. That data is just not present. And then finally, we prepared the violations to be inserted into a separate table in our relational database. We did this in a similar way to what I demonstrated during the cleaning step, where we separated them into individual rows with a separate column for the comment. We then used OpenRefine's fill down command to populate the unique inspection ID and the license number.
We then ended up importing the data from OpenRefine into the MySQL database. We had a couple of issues while doing this. One was that the system kept crashing because it was too much data for the system to handle at one time. So we had to insert the information 50,000 lines at a time. We also ended up having issues with the data types. So coming from OpenRefine, we ended up using the date feature, which when it transferred into MySQL ended up having coming in Zulu format. So we had to go back in OpenRefine and fix that. We also ended up having SQL look for specific data types, and in doing that, it ended up creating limitations. So like in the violations table under violation comments, we had to set the varchar limit to 3,000 just because it's something that isn't auto-generated. It's something that's filled in by the person giving the inspection. There's a couple constraints that you can see. We have two foreign key constraints, one to inspection ID and one to the arbitrary. These are both primary keys and therefore are unique. Another thing that we ended up noticing was that all features had to end up having null values. There is a blank space in every row except for inspection ID and the arbitrary key. And then this week, as we move forward, we're looking into denial mode integrity constraints in the MySQL database.